Hello everyone, welcome back to my channel Learn Math with Priti. The topic which we are continuing today is expressions, formula and equations. This chapter is from grade 7, chapter number 2, and this is the second part of that chapter. We finished 3 subtopics previously, and now the remaining 3 subtopics we will finish in the second video. So we'll start directly with the fourth subtopic. Fourth subtopic is factorizing. I hope you remember and you have checked the previous video. Okay, in that we have finished the first 3 subtopics, and those subtopics are: first was constructing expressions, second one was using expressions and formulae, and the third is expanding the brackets. Now the fourth is factorizing. So what is the meaning of the word factorize? Factorize something means to find the factors. So now this factorizing is just the opposite of what we did in expand. In expand, what did we do? We used to expand the bracket, right? Bracket was given and we used to expand by multiplying the first number with both the numbers in the bracket. In factorizing, we will just do the reverse or opposite of that. Here numbers will be given and you will put the brackets. You will find something common between the two terms and you will put the bracket. That means you will find the factor in between both the terms. So we take an example, 2x plus 4. Anything common in these two numbers? This is an expression, right? So what is common? 2. 2 is common. And what is left in the first term then? X plus. What is left in the second term? 2 2s are 4. So this is what is the answer. So in expand, what did we do? From here to here we found out. Now in factorize, we are going from here to here. Can you see a cycle going on? So we just do the opposite of what we do in expand. We try and find out something in common. Okay. Second is 3x plus 15. So now if you see 3x plus 15, what is the number which is common? 3. So what remains here? It remains x. 3 how many are 15? 3 5s are 15. So the answer is 3 bracket x plus 5. Similarly, there's a small, now we'll take up a little bigger example. If we have 2 variables or 3 variables, sometimes you may have 4 variables also. So not necessarily you can factorize only with 2 variables. You can factorize with 1 variable, 2 variable, 3 variables, or 3 constants, anywhere. Okay, so if it is 2x plus 6y plus 8, now if you see there are 2 variables also, 2 coefficients and 1 constant here, right? These x and y are variables, 2 6 are coefficients of them, and 8 is a constant. Now what is common in between all the 3 terms? The 3 terms are 2x, 6y and 8. So if I say 2 is common, everything is divisible by 2. So if 2 is common, what is left here? X plus 2, how many are 6? 2 3s are 3y plus 2, how many are 8? 2 4s are. So these are very simple example, very simple. What we do in expand, we just do the opposite of that. There we try to remove the bracket. Here we are trying to put the bracket back. Okay, so we will take up one more example for this question, which is a little different. Okay, if you see, there are 2 rectangles, rectangle A and rectangle B. The width of this rectangle is 2A and the width of this rectangle is 3D. Okay, length of this rectangle is L1 and this is L2. We don't know that, but we know the area of rectangle A is 2A square plus 18A, and the perimeter of rectangle B is 14D minus 10C. That means the area for this rectangle and the perimeter for this rectangle is already given, and width is given. What do we have to find out? Length. Can we just do that? Right? We can do that. How do we do that? We just use the formula here for area and here we will use the formula for perimeter, because what is given we will use that only. So area of rectangle, the formula is length into breadth, right? So what is the area given? 2a square plus 18a. Length is L1 into breadth is 2a. Now if you see here, we will factorize this side, na? Because we need to find anything in common this side. So what is common here? If you see, 2 also is common and a also is common. Both are common because a is also present in both the terms and 2 also. So what is left in the first term? 2 and a is outside, only one a is left because it's a square. A square means 2a. Now here what is left? 2 9s are, and a is already common, so we don't write a again. And L1 into 2a. Now I want to find the value of L1, so I'll have to shift this 2a. This is in multiplication, so it will come in division. So 2a, a plus 9 upon 2a is equals to L1. 2a and 2a will get cancelled, right? It is in division. So what is length? A plus 9. So L1 is a plus 9. Okay. So we done finding L1. Now we will go towards L2. What is the formula for perimeter? Perimeter of rectangle is 2 times length plus breadth. Perimeter means it is the addition of all the sides, right? Addition of all the sides means length plus breadth plus length plus breadth. So 2 times length plus breadth. So what is the perimeter? 14d minus 10c is equals to 2 times L2 plus 3d. Now there is already a bracket there, and we need to put up a bracket here because there is no bracket here. We can take something common. So let's take again 2 common. 2 7s are and 2 5s are is equals to 2 L2 plus 3d. Next we'll shift 2 this side, so 2 and 2 will get cancelled. So now we have 7d minus 5c is equals to L2 plus 3d. Now we have to find the value of L2, so we need to shift 3d. It isn't plus, if it goes to the other side it becomes minus. So 7d minus 5c minus 3d is equals to L2. Collect the like terms. 7d minus 3d will be 4d minus 5c. So the length of this second rectangle is 4d minus 5c. 4d minus 5c is equals to L2, and L1 is a plus 9. So you understood how to find out the length in the form of an expression only. Okay, the length here also is given in the form of expression, but how do we find out? We factorize them. We change the subject. What did we use here? Here we did factorization. Here we change the subject and we find the value in the form of an expression. Here also what did we do? We did factorization first, then we changed the subject here, and then we found the value in the form of expression. So this is how you have to solve expression, that is how you have to factorize the questions. Okay, next topic now to start, that is the 5th topic of this chapter, is constructing and solving equation. So this topic actually half we have done already. Constructing equation we have already done as our first topic, right? Constructing equation means we need to make our own equation from the given words. But there we only made the equation and wrote, but here we will make the equation and also solve them. Here we will also solve them. Okay, so in the first subtopic we just learned how to construct the equation and write it in the form of an expression or equation. Okay, now what do? We write the equation and then we solve and get the value of the unknown also. Okay, for that let's take up an example. we'll take up 2-3 examples so we understand better. This is a triangle. Okay, so it's an isosceles triangle. 6x minus 3 this side, and this is 9. Okay, what is the meaning of an isosceles triangle? I hope everyone knows. If not, I'll just explain in short. Isosceles triangle is a triangle which has these two sides same and these two angles are also same. Okay, so leaving the base, the two sides and the two angles are same. That is isosceles triangle. So this is isosceles triangle. That means this and this side is the same. Now they are telling us to find the value of x. How do we find the value of x? Now as we know one thing, that this side is equal to this side, right? This mark shows that these two sides are equal. So we will write them equal. 6x minus 3 is equals to 9. So what did this become? This becomes an equation. After getting an equation, what do? We start solving the equation. So to solve the equation, we need to find the value of x, right? So first, what do we move? As I told you, we try and move this here to the other side, because you cannot move. 6 is the coefficient of x. You cannot move the coefficient directly. So first you will move minus 3. So this becomes 9 plus 3. That becomes 12. Now x, 6 is in multiplication. It goes in division. 12 divided by 6 will give us 2. So the value of x is 2 centimeter. Okay, and if they tell you to find the side, you already know the side is 9 centimeter, right? Side is already 9, but they are asking is the value of 2. Let's take up one more easy example with another shape. That was triangle. Now let us take a rectangle. This is 37, this is 20, this is 2 bracket y plus 3, and this is 5x minus 3. Okay, so the sides of the rectangle are given, but these two are given in the form of an expression, and these two are given in the form of the numbers. So I know this also is 37 only, because opposite sides of the rectangle are same, right? So this side also is equal to 20. We know that. So we are not finding out the side. What are we finding out? We're finding out the two unknown here, that is x and y, the two variables. We need to find the value of x and y. How do we do that? We know that this side is equal to 37. So simply we will write this expression as equal to 37. Okay. So we will write 5x minus 3 is equals to 37. Now what do? We will solve this. 3 goes that side. This becomes 5x is equals to 37 plus 3. Subtraction becomes addition. So this is 5x is equals to 40. So what is the value of x? X is 40 divided by 5, which is equals to 8. So we got the value of x as 8. Now let's move to finding out the other one, y. So 2y plus 3 is equals to, this side is equals to obviously 20. So first what I will move? First I'll move 2 and not 3, because the 2 is outside the bracket. So y plus 3 will be 20 divided by 2, which is equals to 10. So y plus 3 is equals to 10. Now we will shift 3 over that side. So plus goes that side, becomes minus. So 10 minus 3. So the value of y is 7. So we got the value of x as 8 and y as 7. Now let's take up one more example, and the last example to solve questions like construct the equations and solve the equations also. So the last example for this topic is, the diagram shows the size of the two equal angles in the isosceles triangle. Can you again see this is an isosceles triangle, right? So that means this side and this side will be equal, right? So this side and this side is equal. The base is not equal. Similarly, I told that this angle and this angle will also be equal, right? So that means, can I say 4x minus 6 will be equal to 2x plus 18. Okay, we know that these two angles are equal. They told us to write the equation to represent the problem. So this is the equation is already ready. After writing the equation, the B question says us to solve the equation and find the value of x. That means we have to find the value of this unknown x. So collect the like terms. So this will go here and number will come on this side. This will be 4x minus 2x is equals to 18 plus 6. So this will be 2x is equals to 24. So the value of x is 12. So we found out the value of x also. Now third question says work out the size of each of the angles. So we just work out any of the angles. It's the same, right? So we will work out this 4x minus 6. So 4 into 12 minus 6. So 12 fours are is 48 minus 6 will be 42. So we got this one angle as 42, right? So if one angle is 42, the other is also 42 at the base. So 42 and 42. What will be the third angle? How do we find the third angle? Very easy. Sum of angles of a triangle is 180, right? So 42 plus 42, that's 84. So we will subtract 180 minus 84. The answer is 96. So 96 degrees. So the three angles of the given triangle is 42, 42 and 96. That means if the triangle is like this is 42, this is 42 and this is 96. Okay. So that's it for this topic, fifth subtopic. Okay. Now we will start the next subtopic, that is 2.6. The last subtopic of this chapter is inequalities. Okay, what is the meaning of this word inequality? Unequal, the word is very self-explanatory. Unequal means something which is not equal. Yes, so something which is not equal means just not equal is unequal. So there should be a sign of everything, right? When you write equal to, there is a sign of that. So inequality, there need to be some signs of inequality also. There are 4 signs of inequality. That's less than, greater than, less than equal to, greater than equal to, right? So these are the 4 signs of inequalities. To explain, I'll just explain you. 12 is less than 15, right? Where the mouth is open, that is the greater number. Similarly, 15 is greater than 12. If something is less than, so if you want to write something is less than, so if I can say x is less than equal to 12, that means x can be any number from 1 to 12 and y can be greater than equal to 5. That means y can be any number which is greater than or equal to 5. So these are the 4 signs, and what is the meaning of all those 4 signs of inequality? Okay, so this is the meaning: less than, greater than, less than equal to and greater than equal to. So these are the 4 signs and their explanation. So there is nothing more to explain on this. We will just take up the examples directly. Okay, so the question is, if you see here, it's written write each statement as an inequality, and the first one is done for you. So first one is already done, that is y is greater than or equal to 3 and less than 17. This is written in words. They have written in the form of the inequality. Now we will do the same with the second one. For the second one, y is greater than 15 and less than 25. So we'll write y here. It is greater than 15. So then greater than sign. Y is greater than will be here 15. But y is less than 25. So it is greater than, less than. It's not equal to. We will not put any sign here. Y is greater than minus 2. So again y is here. Greater than sign will come here. Greater than minus 2 and less than or equal to 5. So less than or equal to 5. So when they say less than equal to, then you put the line. If it is only less than or greater than, we put only the sign. D y is greater than or equal to minus 9. So again y greater than or equal to both. So greater than and equal to minus 9 and less than or equal to minus 3. Okay, so this is how we write the inequalities written in words in the form of inequality. So some statements are given in the words, we need to write it in the form of inequality. This is the way we write it in the form of inequality. Now sometimes the inequality forms are given like this and you have to draw a number line. So let's take up that question also. Or sometimes what happens, already the inequality is given, you have to write it in the form of words. So let's take up one example regarding that also. Okay, so if there is one inequality given like 3 less than equal to y is less than 9. Okay, so how do we write that? What we will do, y is greater than or equal to 3 and less than 9. This is the way of writing. Okay, so if words are given, we need to write it in the form of inequality, which we did in the previous slide. And in this slide, inequality was given, we wrote it in the form of a word. Now sometimes what is there, inequality again is given and we need to show it on the number line. Okay, and I hope you all know number line. I'll just explain in rough. On the number line, 0 is in the middle. This side we have all positive number and the other side we have all negative numbers. There are many. I'm just writing. So I'm just explaining what is a number line. A number line is a line in which 0 is in the middle and 1, 2, 3, 4 those are in the right side and minus 1, minus 2, minus 3 on the left side. So let's take up an example again. So if a question is given in a form of inequality, it is 6 less than equal to x less than equal to 9. How do we represent this on a number line? First, we draw a number line. We not draw the entire number line. We will draw a part of the number line, not the entire one. Now we number from 6 to 9. So I'll just start with 5, 6, 7, 8, 9 and 10. Only one part of the number line we will draw. Now with the numbers which we want are 6 and 9, just draw two circles on the numbers 6 and 9. I'm drawing it above the line so that it is visible for you and then we will join them. Now that means the x is going to range from 6 to 9. It can be 7 and 8, but it is also given equal to. Equal to, that means x can also be 6 or 9. That means wherever we have equal to, you color the circle also. Okay, if there is no equal to, we don't color the circle. So for that, let's take up one more example. Okay, the second example is minus 4 less than equal to x less than 1. So again we will draw a number line. Minus 4, minus 3, minus 2, minus 1, 0, 1, 2. Suppose we have numbers from minus 4 to 1. Again we will draw first circle on minus 4 and the second number is 1. We draw a circle, then we join them with the line. Now where equal to sign is there, you will just color the circle there only. There is no equal to sign this side, so please don't color the circle this side. Okay, let's take up the last example. The third one is minus 1 less than x is less than 3. Okay, so now if you see here, this is minus 2, minus 1, 0, 1, 2, 3, 4. I'm drawing only a part of the number line which is required by us. So the first circle I'll make on minus 1, the second circle we'll make on 3, then we will join the dots. Now is it required to color any dots? No. So always remember, if it is only less than or greater than, so we will not color the circle. But if it's less than equal to or greater than equal to, we will color the circle. Very easy to remember. That means only less than greater than will not color the circle. If less than equal to greater than equal to, we will color the circle. So that's it for this subtopic also. So we have finished the second chapter also. All the 6 subtopics of this chapter are done. Okay, so I have also taken many of the examples in this only. Okay, so I hope if you have any doubts, please comment below. So that's it for this chapter. See you in the next video. Till then, thank you for watching.